Hello dear students. So after completing the classification of matter, we are going to start with properties of matter. So in properties, we will discuss two types of properties, that is physical properties and chemical properties. First of all, the physical properties. So physical properties, they involve basically the state of the substance, shape, color, odor. Now let us take into consideration a ball, right? So ball will be, as per its state, it's a solid. It is round in shape. Its color, as seen, it's yellow, and odor will be rubber-like. In the same manner, if we relate with sulfur, so sulfur is again, it exists as solid crystal. The shape is not specific, not defined, but the color is yellow and it has strong odor, right? So these are the physical properties. Apart from this, or we can include color, length, mass, area, texture, elasticity, odor, melting point and boiling point. These are the examples of physical properties to analyze any substance. Now for physical properties, as we have analyzed sulfur and that ball, rubber ball, so there is a problem that certain other substances, they may look like or they may possess the same properties, right? They may be yellow in color, they may be having specific shape, right? So on the basis of physical properties, we cannot draw all the conclusions regarding a substance. As a result, we have to go to the chemical properties to distinguish between the two substances more appropriately, right? So chemical properties, they include flammability, because the flame of the substance, that may vary, its color may vary, right? Then what is the reactivity of the substance towards acid, that can be predicted and it will be specific for specific substance. Then in the same manner, reactivity towards water. So the detailed information about a substance is predicted on the basis of chemical properties. Now during the analysis, while analyzing for chemical properties, right, the quantitative aspects, they are covered, and for that measurements are required. And for measurement, always remember, measurement involves numeric value and unit. For example, this piece, it is being weighed, so 200 is the numeric value, and then unit used will be gram, that is, which is used for mass or weight. Okay, so for measurement, initially there were two systems. One was English system and another one was metric system. This English system, it includes, for example, yard, foot, then inches, miles, gallons, right? These are the units of measurements under English system. But there was no proper system to relate these systems. What is the relation between different systems? It was not there. So for that, metric system was introduced. And in this metric system, multiples of powers of 10 was used. For example, 1 kilometer equals to 10 raised to power 3 meters. So 1 kilometer will be equal to 10 into 10 into 10 meter. Okay, so this system was used, and later on international system of units were used under this metric system. And this international system of units, which is called as SI system internationally, it was universally accepted. Now we will discuss more about the physical quantities and their units. So the fundamental units were, there were 7 fundamental units. SI units of measurement. It included a length, this is the property, physical property, and the unit was meter. This comes under SI system. So SI system covers the fundamental quantities and units. Length, then mass. For mass, kilogram was used. For time, second was used as unit. Electric current, it was ampere. Then thermodynamic temperature, that is Kelvin. Amount of substance, that is mole, very important. And then luminous intensity, candela. So all this was under SI system of units. Okay. Now these are the basic physical quantities, their symbols, SI units and symbol for SI units. You have to remember this table. Length, symbol is small l, meter is the unit, and it is represented by m. For mass, m, kilogram, kg. Time, symbol is t, and the unit is second. Unit, we will use the term s, not SEC. Sometimes children, they used to write SEC. This should not be used. It will be simple s, small s. Then electric current, it is represented by I. Its unit is ampere and represented by capital A. Then in the same manner, physical quantity is thermodynamic temperature. Symbol will be capital T and unit will be Kelvin, K. Then amount of substance, small n, unit is mole and it is represented by MOL. Luminous intensity, LV, unit is candela and it is represented by CD. So these are the basic fundamental units. These are the fundamental units. Okay, there are 7 fundamental units. Okay. Now we will discuss some of the properties, that is mass, very important. But in chemistry generally we use both the terms, that is mass and weight. Are they both same? They are not. Mass and weight both are different, as mass is the amount of matter present in a substance, whereas weight, the gravitational force exerted on a substance. So this mass and weight, they tends to vary as the gravitational pull that changes. Okay. For example, on the surface of Earth, if the mass of a person is 120 kg, what will be its weight? So its weight will be 1200 Newton. Whereas if the same person with mass 120 kg is present on moon, so his weight will be 200 Newtons. This is due to that force or gravitational pull, because gravitational pull on Earth is different than that of on moon, right? So, but generally as we discuss very small things, we talk about microscopic particles. Microscopic particles are taken into consideration in chemistry. So for an electron whose mass is very small, how can we distinguish between mass and weight? So there will be very less difference between mass of weight. So generally in chemistry, particularly in chemistry, we tend to relate both the things for microscopic objects. But for macroscopic objects, mass and weight are totally different. But in chemistry, it might be used sometimes that both the terms, they can be related. Reason being, I think now it's clear to you. Reason being, because the particles are very small. So there will be very minute change between their mass and weight. But otherwise both the quantities are totally different. Then this is the instrument which is used to calculate the weight or mass of a substance. Mass of a substance, not weight, mass. But I think now it's clear. Mass and weight, don't get confused between mass and weight in chemistry. Okay. So this is analytical balance. In practicals of Prep +1, you will analyze this, right? This is the actual instrument which is used to weigh a substance. Okay. Now the next property is volume. So volume, as you know, it is length into length into length, right? As you can see in this cube, So this cube L length, length and length. So it will be L cube. Okay. Now the unit that can be used as liter. So liter can be related as decimeter cube or 1000 centimeter cube. In smaller cases, for example, this block is taken out of this hole. So for the smaller units, we can use centimeter cube. So 1 centimeter cube will be equal to 1 milliliter. So on. A table is given in your book. So you have to relate all these units, right? Now the substances through which we can measure the volume. So generally we use graduated cylinder in chemistry. Then burettes are used as well as pipettes. These are used, okay, in order to calculate the volume. Then next property is density. Density is mass of the substance per unit volume, right? Mass per unit volume, how heavier a substance may be, that depends on its density. For example, ice that floats on the surface of water. So reason being that ice being lighter because it has lower density than that of water. And then the SI unit of density, that will be SI unit of mass, which is kg, and then divided by SI unit of volume, that is meter cube. So the final unit of density that comes out to be kg meter inverse cube, okay, kg per meter cube, right? These are all the units you have also studied in physics, so you have to remember these units. Now the next property is temperature, again important property. And in this case, the three scales which were used, one was Fahrenheit scale, right, which has the initial point 32 degree Fahrenheit to 212 degree Fahrenheit, and there was gap of or interval of 180 degree Fahrenheit. Okay, this was Fahrenheit scale. It's divided into three parts, that is where water freezes, that was 32 degree Fahrenheit, then the normal body temperature, that is 98.6 Fahrenheit, and water boils at 212 degree Fahrenheit. In the same manner, second scale, which is most commonly used, that is Celsius scale, this was used, and in this case it is divided into 100 degree interval. Water freezes at 0 degree Celsius, normal body temperature is 37 degree Celsius, and water boils at 100 degree Celsius. So the second scale or the most common scale used is Celsius scale. Then another scale was Kelvin scale. Kelvin scale, again it is divided into 100 intervals. Water freezes at 273 Kelvin. Normal body temperature is 310 Kelvin and water boils at 373 Kelvin, right? Now in SI system we use Kelvin. So this scale will be used and you can relate all these scales. So first of all, relation between Kelvin scale and that of degree Celsius scale, which is most commonly used scale. So as you can see that the initial point in degree Celsius is 0 degree and in Kelvin scale it is 273 Kelvin. So it can be related as that 0 degree Celsius will be 273 equal to 273 Kelvin in Kelvin scale. So temperature in Kelvin can be calculated. If we are to change degree Celsius into Kelvin, so what we will do, we will just add that temperature in we will take that temperature in degree Celsius and will add 273 to that. For example, if 25 degree Celsius is to be changed into Kelvin, so what we will do, we will add 273 plus 25, which comes out to be 298. So it will be 298 Kelvin. So 25 degrees Celsius in Kelvin scale will be 298. So this is the relation between the two scales. In the same manner, we can also relate Celsius scale with Fahrenheit scale, but generally we don't use these two terms, but in the previous classes you might have come across this. So as you know that 0 degrees Celsius will be equal to 32 Fahrenheit, right? And 100 degrees Celsius it will be equal to 212 degree Fahrenheit. So we can relate that there is gap of 180, right? Or we can say 5 degrees Celsius will be equal to 9 degree Fahrenheit. As a result, degrees Celsius can be converted as 5 by 9 Fahrenheit minus 32. In the same manner, if we are to change to Fahrenheit, so it will be 9 by 5 degrees Celsius plus 32. Okay, so this is how we can relate, and in this case this part is most important, so do remember this. Now after completing this physical properties, now generally it has seen that while carrying out measurements in chemistry, because we are dealing with microscopic objects, right? So microscopic particles, they have very small measurements. For example, Avogadro's number. Avogadro's number, it has 6022 and then 20 zeros are there, right? So it becomes very difficult to carry out calculations or mathematical calculations using such numbers. Okay, very large values, how to calculate, how to multiply, how to divide, how to carry out addition. So in order to make it easier, scientific notation is used, or exponential notation, in which we use to specify the large numbers in exponential term. For example, 10 raised to power minus 6, 10 raised to power minus 3, n into 10 raised to power n. This is the method which is used, where n stands for coefficient, right? And this small n, it stands for exponent. So it will be coefficient. Coefficient will be this capital N, and this small n is called as exponent. As you can see in this case, this n, this is coefficient, and this small n is known as exponent. Is it clear? So now that Avogadro's number can be represented as, in exponential term, 6.022 into 10 raised to power 23. Okay, so this makes easier to carry out calculations using large numbers. So scientific notation again, n into 10 raised to power n, where this n is called as coefficient and this small n is called as exponent. And values of exponent, that can be either in positive or they might be in negative, whereas coefficient value, it should be between 1 to 10, right? This is again very important to carry out calculations. Now we will take certain examples. For example, we are given a number that is 0.0493604. Now how to express this number in exponential term? So we will shift this digit, this decimal, how many? Up to one non-zero digit. By rule, it has to be changed up to one non-zero digit, right? It can be converted in both, it can be changed from both the directions, right? As in this case, it is 0.04, so we have to convert it, we have to shift it towards right, towards this direction. How many places? 2 places. So now, as you can see, it comes out to be 4.9. Now that decimal comes here, and 4.93604 into 10 raised to power minus 2. Because whenever that decimal shifts towards right side, from left to right, the exponential, that n is expressed in negative. Do remember this. And whenever the decimal shifts from right side towards left, so n will always be written in positive. That is, exponent will be always in positive. This is very, very important. So exponent in this case is minus 2 because it has shifted 2 places towards right. Right? Now we will take some examples of addition, multiplication, subtraction and division using exponential term. How to add exponential terms. So this is again very important, although students, they have already studied in previous classes, but do remember once again. Now a and b can be any number, they can be any coefficients, into 10 raised to power n. So this n, 10 raised to power n exponent has to be taken into consideration. So for carrying out addition, we will add these coefficients, but this n value has to be same, and then this n is taken as common, right? 10 raised to power n is taken as common once these are equated, and then we will simply add these. In the same manner for subtraction, we have to equate these n and then taking them common, and then the two coefficients, they can be subtracted. For example, now an example is taken. So it is 6.62 into 10 raised to power 4, and it is 4.31 into 10 raised to power 3. Now you can see that the exponents, they have different values. So generally what we used to do, we will change the exponent which has smaller value, we will equate it equal to the larger one, and for that we have to shift the decimal. Okay, as you can see here, now it has to be changed, this exponent, and this exponent can be written as, you can see 10 raised to power 4 is there, we have shifted, we have written it, we have shifted this decimal places towards this side. So whenever that decimal it shifts from right towards left, the exponents will be increased in positive. So it will be written as 0.431 into 10 raised to power 4. So we can write as it's shown here. This is very important. So once it's there, the two exponents are equated, then we will take this 10 raised to power 4 as common factor, and we will add 6.62 plus 0.431. So we will get our answer. I think this is quite easy, but just to remember. Okay, don't get confused in this. Then examples, this was for addition. Now for subtraction. Now let us say this is the example 3.42 into 10 raised to power minus 5, and it's minus, we have to carry out subtraction, 2.5 into 10 raised to power minus 6, right? So in this case we can change this 10 raised to power, because this value is bigger, so we will change, we will convert this 10 raised to power 6 into 5. So for that it will be written 2. So now again decimal shifts from right towards left, so the exponent will increase by 1 in positive, and it's minus 6 and plus 1, so that will make minus 5. So as a result, minus 5, both are equated. Now take common, 10 raised to power exponent is taken common, and 3.42 can be subtracted. From this 3.42 we can subtract 2.5, we'll get our answer. I hope it is clear to you. Now the next one is examples of multiplication. In multiplication we have to use this formula, a into 10 raised to power x into b into 10 raised to power y. So simply we have to relate that once the powers are same, so they get added up, right? So in this case, or they are different even, then also the base is same, 10 raised to power, 10 raised to power, so they get added up. This is the basic rule. So a into b into 10 raised to power x plus y, and then likewise the example is given, you can go through this. So 2.4 into 10 raised to power 3 into 5.6 into 10 raised to power 4, so 2.4 into 5.6, and then exponents, they get added up, these are multiplied, then you can change this. Now if it has to be written in exponential terms, so scientific notation, so it will be 1.344 into 10 raised to power, now decimal is shifted towards left side, so it will increase by 1. So this will be the exponential expression for this number. Okay, now finally the division. So for division, two numbers will be given, a into 10 raised to power x divided by b into 10 raised to power y. So a and b, they are to be divided, and then exponents, that is denominator, so x minus y, exponents, they can be subtracted. Okay, and then for example 4.7 into 10 raised to power 11 divided by 6.82 into 10 raised to power 5 is given. So this can be shifted once it goes upwards, so it will become negative. So 10 raised to power 4.74 into 10 to the power 11 minus 5, that will give you 6, and divided by 6.82. So finally you will get this, but now it has to be expressed in exponential term. So decimal will shift towards right, so that means one digit will be in negative. So 6 minus 1, so it will be 5. So this was all about how to carry out calculations of exponential terms.